Hello, everyone. Today I want to talk about a topic, and this is all about next generation traffic signal control. And I will discuss about five advanced traffic signal control which are uh, in the field right now. Those are SURTRAC, Scoot 8 AI, Google Green Light, SYTRAC, and V2X. All these five advanced traffic signal control I will discuss. So I am Saurabh Borua, and let's deep dive into the topic. So my discussion is on NextGen TSC, that is traffic signal control. Firstly, I will talk about SURTRAC-style. It uses decentralized multi-agent adaptive control. Next one is Scoot 8 AI. It depends on predictive AI adaptive system. The third one is Google Green Light, developed by Google. It uses data-driven retiming. The fourth one is SYTRAC-style. It uses Edge AI and computer vision adaptive control system. The last one is V2X priority overlay. It uses hybrid V2X priority and adaptive base layer. So all these five traffic signal control I will discuss here. So let's highlight these five smart TSC. We can see that the SURTRAC-style use decentralized adaptive control. It optimizes locally in real time. It uses dynamic programming at intersection and uses the local vehicle arrival data. However, in the Scoot 8 AI, it uses centralized adaptive system, continuously adjust signal timing, use real-time data from the detector and AI enhanced prediction it provides. Then regular Scoot is advanced model of Scoot 8. It is the advanced model of Scoot, and it named as Scoot 8 AI. Then comes the Google Green Light. It is AI powered cloud based system. It optimizes existing traffic control, and this green light system use Google Map to aggregate trajectory data. The best part is that it doesn't require any new hardware. Then comes the SYTRAC-style. It uses adaptive traffic control. It can optimize in real time traffic signal plan, use traffic flow models and feedback loops, and can do continuous data analysis. The V2X priority overlay use connected vehicles. It can grant signal priority, focus on transit, emergency, and specific fit, and it use vehicle to everything communication as described in its name. So let's see the field deployment where they are in application right now. We can see that the SURTRAC is used in Pittsburgh, Atlanta, various Miami, various locations in USA, and almost 50 intersections in Pittsburgh are using SURTRAC-style uh, adaptive traffic signal control. Scoot 8 AI users in UK, especially in Milton Keynes, and also transport for Greater Manchester. Almost 350 cities use this technology, and it builds on the long established Scoot deployment. Google Greenlight is used in Boston, Seattle, also used some cities like Vancouver, Quebec in Canada, Brazil, Germany, even in Hyderabad, Bengaluru, and Calcutta. In India, Google Greenlight is used. Also, Abu Dhabi, Budapest also use Google Greenlight. Almost 18 to 20 cities across 4 continents use this system. The SYTRAC is comparatively less popular in this regard. It is in pilot plotting of intersection in Algeria. It is now deployed. Some cities of Algeria use this low-cost edge AI system. V2X priority overlay is used in northern Texas cities like Arlington, Fort Worth, Garland, also used in Oakland, used in Arizona, Atlanta, and various cities. It actually prioritize or preemption for truck, transit, emergency vehicles. And these are the 5 traffic signal system. Those are right now in deployment in various cities around the world, we can see. So let's first talk about the SURTRAC, which is the abbreviation of Scalable Urban Traffic Control. It is first originated by Carnegie Mellon University, Robotic Institutes, and also developed, commercialized by Rapid Flow Technologies and acquired by Myovision. Is ideal for complex urban grid, dynamic and responsive. It is for especially for incident and closures. In case of closures, it reduces emissions, reduces stops, also increase travel time, control, lower the travel time. And SURTRAC agent is a multi-agent AI. It is schedule driven and single machine scheduling problem it uses, and it can actually real-time vehicle detection are performed by camera and or radar. Pedestrian, cyclist, transit and connected vehicles are detected. Then it uses fully decentralized system, second by second optimized rolling horizon it uses. For neighbor communication, it projects outflow for coordination. If we look at how it works, it detects traffic, then create optimal scheduling. Then in the third step, it communicates with neighboring signals and execute green times. The limitation of SURTRAC is it requires local sensing and computation, so hardware cost rises, relies on high detection quality. It is best for dense irregular urban network, and if we want to develop true real-time adaptive controller, or we want to use true real-time adaptive controller, we can use SURTRAC. Then comes Scoot 8 AI, is the advanced version of most popular Scoot system. We can see that it uses split cycle offset optimization technique, and also powered by AI version. It originally developed by TRL lab in UK, and evolution of classical Scoot system, and latest version is released in 2025. It uses continuous optimization of split cycle and offset using live detector data, forecast demand for 30 minutes ahead, then enable proactive adjustment, also can detect incident and anomaly, network level it can see, and use optimized algorithm to reduce manual intervention. Strength of this method is it is mature because it is based on the original Scoot system, and it is reactive. It is a shift from reactive to proactive system. Broad multimodal future ready features it has, and typically it is good, has good performance and strength in or within 12 months. Key features is it is hardware oriented. Public transport priority, we can include cyclist and pedestrian support is possible, emission estimation can possible, and also integrate with other tool. Flexible communication is strength. The limitation is it is more centralized and network oriented, and there is no decentralized system here. And traditional version, it depends on traditional version to reduce the delay or objectives, and performance depends on detector coverage. Obviously, if we have less number of detectors, it will not perform good. It is best for which the cities which already has SCOOT and UTC system, and those city need to extend the SCOOT system. So in that case, SCOOT 8 AI is better. Once predictive capabilities and proven reliability at scale, large scale, even we can, it has some reliability, so we can consider it. Then comes the Google green light. This is AI powered traffic flow optimization. It uses aggregated map data, especially the Google map data, then plug into the machine learning data process. Then timing recommendation are obtained. Those are actionable adjustment to green split, offset, and waves. City engineers then can review the recommendation and continuously monitor and implement the system. It is possible for real-time feedback. Key strength of it, it is no hardware cost, almost zero hardware cost. Quick deployment is possible. It reduces emission and is scalable for Google Map data. Limitation is periodic and human approved recommendation is required, relies on map data density, and less effective for low data or low volume areas where there is not enough probe data. Not suitable for multimodal sensing or priority. Overall traffic flow, because it discussed work with the overall traffic flow. And it is best for budget constraint, where there is budget constraint, low effort, emission focus, we can use it. It is expanded to almost 20 cities like Boston, Rio de Janeiro, Hamburg, Vancouver, and various cities. It is deployed. Then comes the SYTRAC. If we look at the SYTRAC, it uses Edge AI intelligent traffic control system. The research system is developed in 2025 to 2026. Originally, it combines computer vision research system for smart city application, and computer vision and industrial control are combined together. It uses cameras to feed, then Edge AI controller of NVIDIA use deep learning of yellow V4 tiny model, and vehicle detection and counting is done. After dynamic timing calculation, it minimize delay, and lymph node stability is also calculated. The strength of it is low cost, because the camera cost is only 1200 to 1300 USD. It combines modern vision-based adaptability with industrial gate safety, programmable logic control, and isolation for reliability. It reduces delay and resource, suitable for resource constrained municipalities. If we look at the other, it uses communication safety for PLC, and also send the information to the control traffic lights. It has watchdog fallback system and galvanized isolation, certified fail safe. All these are integrated in the industrial safety PLC for system architecture. The limitation of the SYTRAC is newer, less mature than SURTRAC and SCOOT, less widely deployed, and primary local or edge focus, less network-wide coordination. We can see it is best for small cities where need affordable solution, individual intersection with unique needs. Adaptive control with strong safety hardware is required, because it ensure industrial safety PLC system, which is provided by Siemens S7 to 1200, and it has standard compliance system. So in that point of view, it has some good features. If we look at the V2X priority overlay, we can see that it actually targeted vehicle signal priority system. Strength of the system is faster emergency response improve transit reliability, lower fuel use and emission, and works with existing controller system, and interoperability is best part. It is actually originated from vehicle to everything technology for signal priority and preemption, deployed or trailed by the Oakland County of Miami, Europe, and various cities. Then comes, if we talk about how it works, we can see that the onboard vehicle then take information from the onboard vehicle. It uses standard message, SPAT or map. Then roadside unit, RSU at intersection also get information. Multi-band communication sent to the traffic signal controller. Then integration with the optical preemption, existing traffic signal, request granted, green extension, early green, and fully preemption within safety rules are employed. And best part is within 10 seconds, average travel time saving, substantial green light rate improvement, and you can see that the reduction of especially the transit crossing time will be reduced. The limitation of this V2X priority overlay, it is not general traffic optimizer, primary serves equipped vehicle, secondary benefit to general traffic, required equipment cost on board unit and roadside unit works together, depends on penetration rate, effectiveness scale with adoption. The best part of V2X priority overlay is emergency response agencies, priority public transport authorities can use, also freight corridor. It is for freight corridor it can use. So this is the fifth system, the traffic control system that I want to talk. If we look at the side-by-side comparison, we can see as a controller, SURTRAC is a fully decentralized real-time adaptive signal, whereas Scoot 8 AI is adaptive and predictive. Google Greenlight is periodic AI recommendation, and SYTRAC-style use Edge AI, real-time adaptive system. V2X priority overlay use priority and preemption overlay. The primary data used by SURTRAC is local sensors, that is camera, radar, and neighbor schedules, whereas Scoot 8 AI use detectors, AI forecast, and Google Greenlight use maps or probe data. SYTRAC use yellow and computer vision. V2X sends messages from equipped vehicle. Responsive point of view, SURTRAC is second by second, works on second by second. Scoot works cycle by cycle. 13 can provide 30-minute prediction. Google Greenlight minute to hour to implement. SYTRAC use real-time edge, and V2X use on request, near immediate. It can work. Hardware needs, SURTRAC needs sensors and local computer per intersection. Scoot 8 AI need hardware agnostic and need detectors. Google Greenlight do not need any new device, where SYTRAC-style use camera and PLC system. V2X priority overlay need onboard unit and roadside unit both together. From cost point of view, SURTRAC is cost is moderate per intersection. Scoot is moderate to high. Google Green is very low and is almost free to city. SYTRAC is low, and cost of V2X priority scales with vehicle and site. Key strength of SURTRAC is it works on complex grid, multimodal, and proven large gains. Scoot can work with large scale, prediction, and maturity. Zero Greenlight use zero infrastructure cost, easy emission wins. SYTRAC is affordable and industrial safety is embedded with it. V2X priority is targeted on priority of transit and emergency vehicle. If we look at the typical gains, travel time and weight is a gain for SURTRAC. Scoot use priority and historical delay cut. Google Greenlight can reduce stops and emission. SYTRAC assumed 22% delay reduction, whereas V2X priority reduced 10 seconds per intersection priority vehicle time less. Maturity and deployment, if we look, SURTRAC is used in multiple US and Canadian cities. Scoot 8 is used in almost 350 cities, and AI is new here along with the classical Scoot. Google Greenlight used 20 plus cities expanding. SYTRAC is research and field prototype mainly. V2X is growing trial and deployment. Scalability point of view, SURTRAC has good scalability, excellent for decentralized. For network-based, centralized control system, Scoot is better. Google Greenlight is also excellent, data-driven. SYTRAC is good for local or specific sites. V2X depends on vehicle penetration. This is all about the comparison, and this is the end of the presentation that I want to present here. Thank you so much for watching my presentation.